And why don't I try to cheat you today? Pull your leg. So how about if we think now solve a problem which actually somebody gave a suggestion. So let's use a virtual object and a convex mirror and see where the image would be. And I will also measure the value so we can locate the relate position of the object with the position of the image. Let's say that I have a convex mirror here. This is the plane of the mirror, and let's say that light is coming from the left-hand side, and I want now to use to have a virtual object. So where should I mark that object? Now let's say that let's recognize that it is a convex mirror. So focal point is on the other side. So from this side is light. Focal point is on the other side, and I made it focal length is 20 centimeters. Now I want to put or to place somewhere a virtual object. Let's say at location 40 centimeters from the mirror. Where should I mark that point? That object. Well, light is coming up from this side, and if it is virtual object, it means that the rays converge to a point. It is on the other side of the lens. So over here, we have object, and I will mark it with a broken line to indicate that it's a virtual object. All right. Now suggest me which rays to use, and I will try to pull your leg and make and draw it improperly. I want you to fix it. So which ray would you like to use? Object parallel ray. Okay, so I'll use object parallel ray, and to confuse you more, I will use just one color. How about if I use this black one? So I'll mark here object ray. Who buys it? Is it correct? No, it's wrong. Yeah, how should I mark object ray? How? Object parallel ray. What's wrong with this object parallel ray? A what? The light is coming wrong way. Correct. The light is coming wrong way. Now, should I mark it this way then? It's better, although it's still not good. I still don't like it. Use continuous lines to indicate that this is ray, not its extension. For extensions, I want you to use broken lines. So this line should be broken. Now, I should mark somewhere where the ray really is. Where is the light? Very good, Owen. It's on the other side. Object parallel ray looks like that. It is traveling in front of the mirror. Here is the mirror on this side. So over here I should mark it as a continuous line. All right. Now, what will happen with the light traveling along the parallel object ray after it is reflected? Yeah, so the ray or its extension has now to pass through the focal point. Like this. And I suggest actually to use a different arrow to indicate that it's an image. No, I won't. How about if I mark it that way to confuse you? I'm glad that you noticed that it's wrong. This is a mirror. Light cannot cross the mirror and travel toward the focal point. Mirror is going to reflect the light. So which way however, either the ray or its extension has to pass through the focal point. It means that this is the extension. So where's the ray? Very good. It's being reflected back. All right, we took care of one ray. Let's use well, in order to find the image, we need at least one more ray. So, Brian, which ray would you like to use? Chief ray. Let's use chief ray. So I know that from here to here it's the extension of the ray, and the ray is on the side where the light is. Is it good? Which chief ray? It's this object chief ray. Owen says, no way, this is wrong. Yeah, what's wrong? The direction, correct. It's the object ray. Object ray meaning that the light is coming toward. All right, so now when it is reflected, let's say that I do it here. So it's reflected symmetrically. Is it right? Owen? And I'm saying that this is the image chief ray. It is right. All right, now there will be a problem with this. Where is the image? How about if I give a suggestion that it's here? Is it right? Who votes that it's right? Who thinks that it's wrong? Okay, who thinks? Or what do you think?
I think it's on the virtual side.
Okay, so what's wrong? What's wrong with the point which I just marked?
Well, one thing was actually going different directions, so I would think of conversion to an image.
Yeah, I confuse. Very good. I confuse the two rays. This is a point where whether an object ray crosses an image ray. Now, I see, that the image is formed by the image rays, and this is why I actually suggest to mark the arrows differently. I marked them on purpose identically because this is very likely you will mark them too. But now how about if I change the image rays? Yeah, so these two rays appear to come from a single point, and that point is the image. So where is the image then? Well, this ray appears to come from this direction. So from all points, all of these points and all points which are on the extension. Okay, now this one, I have to extend this one too. So it looks that the image is here. Now what kind of image is this? Real or virtual? Who votes that it's real? Who votes that it's virtual? Those of you who voted that it's virtual, you are right. Yet the light never gets there. It is the extensions of the reflected rays appear to come from that point. So this is a virtual image. And actually, I mean, there is something. Let's now use lens equation and see that we got it right. Lens equation says that inverse of position of the, inverse of the component of position of the object plus inverse of the component of position of the image is supposed to be equal to the inverse of the focal length. The way I describe it now, I was trying to be very precise. I will accept that you say that S and S prime are positions rather than components of position, although precisely it is a component of position. So how about if we use now the numbers which we had? And let me remind you, I marked focal point 20 centimeters from the surface of the mirror. So what should I put for the focal length? How much? 20 centimeters. Who votes that I should put 20 centimeters? Who thinks that it's another number? It is another number. Eric is close. Yeah. What is F? If I measured here 20 centimeters. Yes, I measured 20 centimeters. Should I put 20 centimeters as the focal length? Cody, what do you want to say? Negative 20. It's a convex. The focal point is behind the mirror. Things which are in front of the mirror should have positive values. All right. Now, I placed object 40 centimeters away from the mirror. What should I have for the component of position of the object? Should I have 40 centimeters? Who buys that? Who thinks that it's a different number? It is a different number. Eric, what is it? Negative 40. And why? Because it is on the other side, correct. Now let's find out where should we have the image, and we'll see how good is our ray diagram. So from this, S prime is equal to 1 over minus 20 centimeters plus 1 over 40 centimeters to minus 1. So it looks to me that it is going to be minus 20 centimeters. Does it make sense? I mean, algebra is fine. You don't have to check algebra. Or if you want, do it on your calculator. Actually, I didn't even calculate. I just saw on the diagram, honestly. So you may check because I did not perform calculation. I just saw from the diagram that this is the number which I should get. Can somebody calculate that? Well, actually, I can do it in my head. This is minus 1/20th plus 1/40th, so the result is going to be minus 1/20th. Absolute value of this number is half of an absolute value of that number, right? So this expression is minus 20 centimeters. If I take an inverse of that, this is 1 over 20. What say? This? Oh, thanks. Right. I confused what is what, right, because I saw that the position of the image is the same as position of the object. Now it makes sense, right? Yeah, because it is consistent indeed. Thank you, actually. So it's good that you grabbed the calculator. All right. Let's now try to do it something else. How about if I actually use the same lens and reverse the problem. I want to have image here. What kind of image I want to have? Real or virtual? Real. Why? Because we see that it's on the side where light travels, reflected light travels. It means that it is supposed to meet here. And I made it 20 centimeters. Should we maybe calculate it first this time? So again, focal length is minus 20 centimeters. Now this distance over here is 20 centimeters. So one of those two should be 20 centimeters. Which one? Can you help me? Or minus 20? Which one? I want this to be the image. The second one, right? So this one. Now, should I have here plus or minus? Should I put plus here or minus? Plus. Oh, it says plus. And why do you say that it's plus? Because the image is in front of the mirror. Correct. So we need plus over here, which means that over here. And this is what we are looking for, where we have to put the object. So from that, S is equal to minus 1 over 20 centimeters. If I move this one to the other side, I will get another 1 over 20 centimeters to minus 1. So from that, I'm going to get minus 10 centimeters. Check if I calculated it right, because it's correct? All right. Which means that where the object should be, somewhere between this is minus 20, so it should be halfway over here. How about if we now make ray diagram? And actually, how about if I make this arrow a little bit bigger so that the drawing is not too small? Which, and how about if I try again, pull your leg when I draw the ray diagram? Suggest me which ray to use. Chief ray. Should I use object chief ray or image chief ray? I should start with drawing object chief ray. How? Who said image chief ray? Oscar, right? Why do you say, what's wrong with object chief ray? Oh, we don't know where object is, right? So we don't have the second point. However, we can start from the image and draw the image chief ray. Should I mark it this way? No. Very good. Should this line be continuous, however? Yes, it should be. Yeah, this is the line along which light does travel. However, it travels away from the mirror. So this is the image ray traveling away. All right, now I can trace the object chief ray, because I know that object chief ray is supposed to be symmetrical about the principal axis. And so it has to go through this point. And should I mark the arrow to the right or to the left? To the right, correct. Object rays travel toward the optical element. All right, so we got one. Suggest me another ray. Focal ray, okay. Now, which focal ray? Object focal ray or image focal ray? Image focal ray, correct, because I still don't know where the object is. I cannot draw object focal ray. However, I can draw image focal ray. Now, I drew a line, and why don't you help me to determine what should be the direction of that line and where it should be broken. Okay, Robert properly indicated that it should be to the left. Now, somewhere the line should be broken. On the other side of the mirror, correct, because it is the extension of the focal ray. Now, image focal ray was obtained from what object ray? Parallel ray, correct. Now, so after reflection of the parallel ray, we got image ray, image focal ray here. So where that parallel ray, where that object parallel ray hit the mirror? Where? Here, higher or lower? Robert says lower. Lower. Here. Scotty, what's your opinion? Symmetrical to what? To what? Symmetrical about what? Or parallel? Here? right there. Mike seems to be pretty convinced that it should be here. I will mark it over here then. And Mike, why don't you? Can you give justification? Why did you pick it here? And it is right. This is object. This has to be object parallel ray. The object parallel ray for coming out from the object forming this image. How do you see it, Mike?
The object parallel ray, when it hits the mirror, it turns into the focal ray,
So,
the image focal ray.
right. It means that it has to hit the mirror at what location?
The same location.
The same as the image ray, focal ray is coming out, right? So when we had this image focal ray, we saw that it is reflected at this point, which means that the parallel ray has to hit the mirror at this point. What'd you say?
It's the normal it's normal to
No, parallel ray is not normal to the surface of the mirror.
parallel ray, the image ray goes off here.
That one?
Yeah.
It's not normal to the surface either. Normal actually is in between. Yeah, remember that angle of incidence has to be equal to angle of reflection, right? So let me magnify this part. So if this was incident ray and this was reflected ray, then the mirror had to be oriented like that at this point. It is curved like this, right? So the normal actually bisects this angle. Yeah, these two angles have to be equal because this is the angle of incidence, this is the angle of reflection. All right. I think that having two rays is sufficient to identify location of the object. However, where is it? Let's try. Is it here? No. Here? Here. So where is it? I have to do something. What? To extend the object rays. Right, because these object rays or their extensions meet at a point where the object is located. Who is happy? Too few people are happy. Talk to each other until you make your neighbor happy. What'd you say?
I think we talked about it yesterday. Where
I didn't use the normal ray here, so just we can come back to normal ray. I mean, just to verify the diagram, we will do that. Now, I want you to be happy with the diagram and tell me why are you happy? Yes, Eric?
I'm happy with that.
Why?
We found where it is located.
And what? This is insufficient to be happy.
It's insufficient.
No, it is insufficient to be happy that we made the diagram correct. It also agrees with the calculation, right? We found that the position of the object is supposed to be minus 10 centimeters. Minus 10 centimeters means behind the mirror, and we had over here behind the mirror as well. Now, since Robert actually brought up problem of the normal whatever, I want to use the normal ray to verify that this point is right. Well, so if focal length is minus 20, it means that the location of the center of curvature is here. Right? Now, let's take a look at the normal ray. All right, so if I start with the normal ray traveling in this direction, this line should be broken, right? And actually this one is broken as well. Now normal ray is reflected back, right? So at this point, actually the light is falling on the mirror perpendicularly to the surface. So when it is reflected, it travels exactly back, and we see that it goes through the, everything agrees now. All right, so this will be all for today then. Thank you for your attention, and see you tomorrow.